Okay, today I'm going to go through a recording of this paper that you did as a Year 11 topic test if you're in my class, and if you're not, it will help you revise for your GCSE. So the topic test was on Units 4 and 5. Sorry about my messy handwriting. I took a lot of the questions from the 2020 papers. It wasn't all from one paper. And this is to prepare students for paper 2, which is the physics IGCSE only. It's not for double award. Okay. You also need to know a little bit about forces to be able to answer all the questions in these topics. As you're in year 11, they expect you to know topics from year 10 as well. Okay, so the first question, here's the formula you get. So paper 2, formula sheet is like this. So the first few you don't need for this paper. For units 4 and 5, you need the ones which I've circled in red, and you need to know specific capacity, and that gravity is 10 meters per second squared, which you can also use as 10 newtons per kilogram. So for Edexcel IGCSE, that's what we use. The first question is from Unit 4, which is on renewable energy resources, which is the only part of the energy topic which isn't in double award. So if you get a question on energy resource, it will be in paper 2. And this is a very easy question for the beginning of the exam. If the question number is low, it means it's from the early part of the exam, and usually the early part of the exam are easier. So they want 3 methods of generating electricity which use renewable energy resources. So you've got to put 3 ticks in correctly. They've already given you the one with the arrow next to it, which is solar cell. So they want you to tick the other 3 for the 3 marks. If you tick too many, they'll take marks off, and there's a mark scheme which is on the next page. You can have a look. Then they want you to explain that regarding solar cells, the ones that they ticked can be used to generate electricity, but how is energy transferred from the sun? Obviously, using solar cells, using the sun's energy. How does sun's energy get to us? Well, it gets to us by radiation. Remember, they want you to know about energy transfer, and this would also be in paper 1. So you need to be able to explain energy transfer mechanisms generally. Okay? So mechanically means it's a physical force that's doing the work. Electrical energy transfer is using a voltage to transfer energy to an electrical component, and heating is by conduction or convection, where the heat transfers from a high temperature to a low temperature from one place to another. So you can actually transfer heat by radiation too, from the hot place to the cold place. So black will absorb more radiation than white, for example. Dull surfaces will absorb more heat radiation than shiny surfaces. And then, so that's basically for it to get through a vacuum from the sun to the earth as a vacuum space. It can only get to us, the energy transfer mechanism is only by radiation. Another form of energy by radiation is sound energy, how you're listening to the audio on this. It basically is anything to do with waves, which is transferring energy. So sound is a form of transferring energy by radiation. Okay, so you have to state one disadvantage of using solar cells to generate electricity, and the disadvantage would be that, of course, you can't use it at night, etc. Okay. Here's the mark scheme, so I'm going to go through it quickly. You can stop the video to have a look at the notes for getting the answers right. 1 mark for each correct tick, and if you get it wrong, they will give you the marks according to the notes on the right hand side, let you work it out. And then there's the answers that I explained to you. For the common sense answers, for example, the first one, they give you any of these 3 points which are shown with the brackets in the brackets for the final point. Will give you marks. Okay, so you can say, for example, solar panels, if you use them in the area of beauty, it's visual pollution, looks ugly, they will even give you something like that. Okay, they take up a lot of space in the lands. That land cannot be used, for example, for other reasons. Okay, and of course you can only use them at daytime, you can't really use them at night. So that's a quick question. The second question is on density, so that you're expected to remember the equation. I haven't written it down for you. I expect you to be able to remember it yourself. So you're meant to use the audio to fill in the missing points. If you know the equation, you write it as a word equation to make sure that they give you the mark. Because if you use the symbols, they're not sure that you know what the symbols stand for. Then once you know the symbols, is rho, m, and v. Rho is for density, as a curly P. It's a Greek letter. They're giving you the mass and the density here underlined in red, and they want you to calculate the third term, which is the volume. And you notice that they're giving you each of the figures, mass and density, in grams and centimeters cubed, so you don't need to change the units to meters cubed or kilograms. So you can do density as grams per centimeter cubed or kilograms per meter cubed, which are technically the correct SI units for this quantity. Now you should give your answer to 3 significant figures, because the data they provided is to 3 significant figures, which is why I've put the answer to 53.7. Okay? Sorry, I don't know what happened there. I must have pressed something. There's 53.7. So the answer should be to 3 significant figures. Yeah? So all the data here is to 3 significant figures. So your answer should be to 3 significant figures as well. Hope that makes sense. Then there's the mark scheme. So you can stop the video and see how they give you the 3 marks. If you only put the answer and you get it wrong, you get 0. So they give you a mark for substitution, 1 for putting the numbers in, and 1 for the units because they haven't given it to you. Okay? The next question is on energy, and this time the hammer is falling from a height of 1.8 meters. Yeah? So if it's falling from a height of 1.8 meters, that's how much potential energy it's got, and the potential energy, yeah, is mgh, which they've actually given to you. So they've given you this equation in the question to help you with this one. It's not on the formula sheet at the beginning of the paper. Okay, so once you know you're going to use potential energy as mgh, you put the m in, which is 1.8. The g is gravitational field strength, which is 10, given to you on a data sheet, and the height that it falls through is given to you on a diagram as 0.95 meters. You'll notice the data they've given you, 1.8 meters and 0.95, are 2 significant figures this time. So the answer this time should be to 2 significant figures. Yeah? 2 significant figures here, 2 significant figures there. So your answer should also be to 2 significant figures. Okay? So this is the exam technique that you need to learn by listening to these videos. It then says the metal worker moves the hammer down to strike the metal. The hammer must have at least 21 joules of energy in its kinetic energy store to be able to deform the metal. Okay? So if it's deforming the metal, which is what metal workers do. Metal workers basically use a hammer to shape a material like a metal, because the metal is malleable. It can be changed into the shape you want it. Explain why the metal worker has to do some extra work, 4 joules of mechanical work, which is physical work, which is force times distance, circled in red, to get the energy to the required amount. Yes? Well, the potential energy, the hammer falling down from 0.95 meters gives you 17 joules, as we worked out in the previous part, but to deform it you need 21 joules, so 4 joules is missing in terms of the energy required. So you've got to be able to explain that for 2 marks. The mark scheme will come at the end of this question. So then it says calculate, if it does have 21 joules, and obviously 21 joules becomes kinetic energy, yeah? Can you work out the velocity that kinetic energy has? Well, you need to know the equation is half mv squared. Yeah? Put all the numbers in. You'll get a mark for putting the numbers in. So you'll get 1 for knowing the equation, 1 for substituting them correctly, 1 for working out the velocity is then the square root of rearranging it to make v squared the subject equation, then square rooting it, and 1 for getting the answer again to 2 significant figures, because all the data in this question is to 2 significant figures. Okay. Then it says, when the hammer hits the metal, the hammer comes to rest without rebounding, which is not realistic, because if you hit something hard, it will rebound a bit. But assuming it's not going to rebound, yeah, suddenly it comes to rest. That means the final velocity is 0, yeah. So if the final velocity is 0 here, the final velocity, there's the initial velocity, which came from here, 4.8, and the time they're given you, they want you to calculate the force involved if it suddenly comes to rest in 0.12 seconds, yeah. So it produces an impulse, and force and the time involved creates a deceleration, yes? So the deceleration is a equals v minus u over t, which is negative, yeah? But they just want you to know the mean force, so that I don't think they're worried about the sign of it. So the deceleration, you use this equation, you put the numbers in, this is with the numbers in, final velocity is 0, initial velocity is 4.8 divided by time, gives you deceleration, multiply the deceleration rate by the mass, and you get the force, which is, again, to two significant figures, is what you should use. Okay, so that bit's done. And here's the mark scheme. So the first bit is substituting to work out the 17 joules of potential energy. And for the explanation of why he needs to put the work in, the idea that the kinetic energy gained, you need to explain that the kinetic energy gained from the gravity isn't enough, that he needs to put a little bit extra in. If you show them maths, as long as you've proven that you know that the kinetic energy gained will be less than the potential energy it had at the start, yeah, and you say, well, the rest of it has to come from physical work, okay? And then the second part, to work out the kinetic energy, is shown you the way that I broke it down to the 4 marks. And if you don't give it to two significant figures, they're accepting 3 significant figures as well, okay? But you shouldn't really put too many significant figures. If you follow my recipe, you will always get the marks, okay? And the final bit, to get the 72 newtons, is basically changing Newton's second law, yeah? They've changed Newton's second law into F equals change in mass, change in momentum over time taken. But I think it's actually easier to do it F equals m v minus u over t, yeah? Because then the mass, that you don't have to calculate the mass twice, yes? So anyway, there's different ways of doing it. It's just maths. So if you can do algebra, you can get the answers, okay? Let's see if I can erase it. How do I erase it? Oh, there it is. Just so you can see the mark scheme underneath, if you want to, okay? Right. The next question is about specific heat capacity and heating ice from minus 17 degrees. So a student does an investigation to determine the temperature time graph for water as it changes state from ice to liquid water. The diagram of the apparatus is shown. You've got a lid on it and insulating material to ensure you don't have thermal energy escaping to the environment and all of it to the surroundings, and all the energy is going into the ice. The immersion heater is the electrical heater inside the rectangular block, which is supplied electrically. So here you're actually doing electrical work, yes? So when we talked about energy transfers, in this question, this is producing the electrical work in this question. So there's the electrical work being done, yeah? And if you remember from electricity, which is not in this test, but you see when electrical work is being done, the work done is voltage is basically work done per unit charge. So if you want to work out the work done, you basically multiply V times Q, and that's electrical work. W equals Q times V. Now, this is very common, and this is a common question for higher level students that they need to realize. So whenever you've got a voltage, it's the amount of energy that's supplied or per unit charge. So the work done is electrical on the ice, and the heat then transfers through the electrical heater by conduction to the ice. Yeah, so that's why it's useful doing Unit 4 and 5 together in this topic test. So once the thermal energy is going into the ice will start melting, and it says the ice has an initial temperature of minus 17 degrees centigrade. So you need to start your graph at minus 17 degrees centigrade, and then after 5 minutes it says the ice begins to melt. Yeah. So obviously for the first 5 minutes it's going from 17 degrees minus 17 degrees to 0 degrees centigrade, and then it takes 6 minutes. After a further 6 minutes the ice is all melted, so 11 minutes to take the ice from minus 17 degrees and to break the bonds sufficiently to put the energy in to distance them into making the change of state to liquid. Okay, so melt all the ice, so 11 minutes in total, and as the investigation continues for a total of 20 minutes. And then so what will happen after 11 minutes? It will be liquid and it will start heating up again. Yeah, so you have to have 20 minutes on your graph. They want you to sketch a graph on the axes shown to show all these different phases, yeah, to show the temperature, how the temperature changes with time, and assume the rate of energy transfer from the heater to the ice is constant. So if it's constant, the increase in temperature should be constant too. So I've drawn a straight line from minus 17 to 5 degrees centigrade, yeah. So it goes from there to 17. Then the next bit is it takes 6 more minutes for all the melting to occur. Yes, so here is ice, then it melts. All the energy during melting goes to weakening the bonds. And then the bonds, instead of being in a crystalline structure for ice, they'll be in a liquid structure where they have more freedom of movement. And then the temperature after 11 minutes increases again. And that's the steepness of the slope is how you work out the specific capacity if you think about it. So that's higher level thinking. All right. And the next bit, it wants you to go into calculating the specific capacity. But before that, they want you to suggest a precaution the student should take to obtain high quality data. So anything common sense, they will give you a mark for. Yeah, so that's 1 mark is for common sense, and we'll look at it on the mark scheme in a minute. But the next bit says, during the experiment, the heater transfers 2,500 joules of energy. Yeah, so that's a heat transfer. So remember, there's heat transfer, there's electrical transfer of work, and there's also mechanical transfer. So in this test, you've met them all. So when the heat is transferred by conduction from the heater to the ice, yes, it's goes as delta Q. Yeah, so here you got delta Q in the equation that they're given to you. Yeah, and this equation is on your exam sheet. Yeah, on your formula sheet. So delta Q, M is the mass. Be careful, the mass is given to you in grams, so you've got to change it into kilograms for the calculation to come out correctly, because the specific capacity is joules per kilogram per degree centigrade change. And so you know C, you know M, you know Q. The only thing you don't know is delta T. Change the equation round and you'll see that delta T will be Q over MC, and the only thing you need to do is put the numbers in the calculator. If you've changed it to kilograms, you'll get a temperature change of 59 degrees centigrade. All right, so only 2 significant figures again, as I explained to you, because you'll see all the data provided, 2,500, 880, 48, they're all 2 significant figures. They haven't given you the third figure. Here's the mark scheme to work out how to get the marks. Yeah, and the sensible answer for this question, make sure the heater is fully submerged, so it all goes into, it's not going to heat the air, for example, if there's any air gaps. Keep the voltage at the constant level. Yes, check that it's staying at constant level, because obviously that's the energy that you're putting in. Yeah. And obviously you also need to measure the current to be able to work out the energy, because voltage times current gives you power, and then the time will give you the energy. Okay, so the electrical energy transfer would be E is V times I times T. Yes, and this is another way of understanding electrical energy transfer. It's voltage times current times time. And if you remember, I said that current times time is also charge. So this, hopefully, you're starting to put the whole syllabus together as you're in year 11. And I did say that not to remove the lid because you want to make sure there's no heat transfer to the surroundings. So all the heat is going in thermal energy, all the thermal energy is going to the ice. Stirring, for example, they'll accept, and repeating and averaging to make sure you get accurate data. These are all different ways of doing this. And then you put the numbers in, get the answer out. There's how you get the 3 marks for the specific capacity equation. Yeah. And then finally, a question which could also come in paper 1. Paper 1, it says there, this is a question about Io, which is a moon of Jupiter. The diagram shows 2 jets of gas from volcanoes. There's 2 volcanoes. Yeah, a smaller volcano. Yeah. Here, there's a smaller volcano. And there's a bigger volcano. So why does the one have bigger eruption? Well, it means that it must be a higher pressure and therefore a higher temperature. So this is to do with kinetic theory of gases. It says the gas particles in Prometheus, which is the smaller volcano, leave the surface of Io and move vertically upwards, and that's because they have kinetic energy, the particles. The particles reach their maximum height when their speed reaches 0. So that once they lose all their kinetic energy, in other words, their kinetic energy will become kinetic potential energy. Okay? So the height gained is due to the kinetic energy they possess. Okay? And it says some particles in Prometheus jet reach a maximum height of 92 kilometers. You've got to put it in meters, so 92,000 meters. So I think this is a good energy transfer equation, which is again why I told you to revise energy when you're doing this topic. Calculate the initial speed of these particles. So you can use the equation they give you, which is v squared equals u squared plus 2as. Yeah. So they want you to work out the initial speed, which is u. Yeah, in this equation, the one with the blue arrow by it, and of these particles as they leave the surface of Io. Now remember, the acceleration due to gravity on Earth is 10, but on Io is given as 1.8. So you can use this equation because you know A, they want you to find out u, and the final velocity will be 0. Yeah? Because it tells you that the final velocity is 0 when it reaches the maximum height. So the maximum height is, at the maximum height, it's going to be 0. And the maximum height will be the s in displacement. So you want to work out s if you use this. I did conversion of energy, yeah, that the kinetic energy becomes the potential energy. The masses cancel. So if you know potential energy and kinetic energy, it actually comes to exactly the same equation. Okay? So if you can work out how I did it, yeah, I've put u squared is equal to 2gh and then square rooted it, which is exactly the same as this equation. In fact, this equation comes from this theory. Yeah? They're connected. So this is for higher level students to be able to understand this level of maths. So you know that 2, you know the gravity here is 1.8. Yeah? So you put that in, multiply by the height gain, and that's 92,000. Then you have to square root it to get u, because obviously we don't want u squared, we want u, and you'll come to 2 significant figures, 580 meters per second. Okay? And again, you should know why it's 2 significant figures. Once you've done that question, it says before the gas particles leave the surface of Io, they're trapped inside a chamber. Yeah, so this is before they erupt. They're trapped inside a chamber. So they're basically, until the pressure builds up high enough, they won't be ejected from the surface. Okay? Explain how the gas particles exert a pressure. Yeah? How do gas particles exert a pressure? So this is the kinetic theory of gases. They're not saying increases the pressure, they just want you to know how it exerts the pressure. Yes? So if they're moving, there's collisions, and the collisions create forces, and the forces creates pressure. That's the thinking that I want you to do. You've got to look at the mark scheme to see how they get 3 marks. Okay? So I'm not handing it to you on a plate. You've got to work out with my words how to answer these questions. The next bit, so you have to look at the mark scheme to see if you got the 3 parts. Okay? So I'm just doing one more time for you. So the particles have kinetic energy, yes, and therefore there's going to be collisions, and collisions leads to force. And what is pressure? Pressure is force per unit area Yeah, collisions with the walls, for example, of the container. All right, hope that makes sense. I'm just using my finger as my pen, so it's coming a little bit messy, but hopefully you get the idea, okay? The next bit, it says they want you to work out changes in pressure when you know the initial temperature, so you're going to use the pressure equation. So it says now, the Tvashtar chamber has the same volume as the Prometheus chamber. So in other words, they're keeping volume as a controlled variable in this question and contain the same number of molecules. So if they've got the same number of molecules and the same temperature, same volume, then you've got two controlled variables. The two things that are changing then are pressure and temperature. And they've given you the temperature of the gas in the Prometheus as 1200 and the temperature of the gas in the other chamber as 1600. So one has a higher temperature, therefore has a higher kinetic energy. They're giving you temperatures in Kelvin, so you don't have to change them. Remember, this law only works if you're in Kelvin, okay, the pressure law. And then they're giving you the pressure in one of the chambers. They're giving you the pressure of the gas in Prometheus, and they're giving it to you in kilopascals. You don't have to change the units because your answer will then come out in kilopascals, so it will save you time. Use the pressure law equation here to calculate the pressure of the gas in the other high pressure chamber. Okay, remember the pressure is higher, so the answer should be greater than 8.2 kilopascals. So the pressure of Tvashtar divided by the temperature of Tvashtar should be the same ratio as the pressure and the temperature in Prometheus. So you would do P1 over P1 over T1 equals P2 over T2. I've changed the 1 into T and the 2 into P to represent the two chambers. And if you do that, you change your final answer you want to work out is the pressure of Tvashtar. So you multiply both sides by the temperature of Tvashtar, which is 1600. Yes, so the ratio will be 16 to 12 ratio of temperatures. Yeah, multiply by the initial pressure, the pressure in the smaller one, and you'll come up with 11 kilopascals. Again, to two significant figures, and all you've got to do is to write that answer in the space provided. Okay. Finally, it then says, explain why the pressure inside the chamber increases when the temperature increases. Now they want you to say what happens when the temperature increases. Well, if the temperature increases, yes, if the temperature goes up, what's going to go up? Kinetic energy goes up. If the kinetic energy goes up, the velocity goes up. If the velocity goes up, the rate of collisions, you have to put rate of collisions will increase. Yes, the rate of collisions will go up. And if the rate of collisions will go up, then the pressure will go up because the forces will increase. So look at the mark scheme to see how you get the three, but that's the stages. So this is a more complicated question. At first, they want you to explain in the previous page, they want you to explain how pressure is produced by collisions of particles. And now they want you to work out why does it increase when the temperature increases, and that's because the rate of collisions increases. So you're going to have more forces involved in per unit time. More forces per unit time means that you're going to get a much higher rate of collisions, and the higher rate of collisions you can work out is going to be linked to pressure, because remember, force per unit area is what pressure is in terms of physics. Okay, hope that makes sense. All right, and let's see what other question they have. I'm actually walking and talking at the same time. Yeah, the final part says explain why the particles from the Tvashtar chamber, reach a greater maximum height. Well, you'll remember that the pressure in Tvashtar was 11 kilopascals, whereas the other one was about 8. So if the pressure is higher, the temperature will be higher. If the temperature is higher, they got more kinetic energy. And if they got more kinetic energy, they got more velocity. Yes? So if they got more velocity, they can go higher because kinetic energy gets converted into the potential energy gain. And if the potential energy, remember, potential energy is mg h, and they're the same particles. Yeah, gravity doesn't change. The only thing that will gain will be the height will increase. So that's how you got to break down the answers into getting the marks. And that's the end of the question. And here is the mark scheme that you can stop, slow down, see where you think you gained the marks, and see how you can improve it. And if you know, if you're one of my students, you know what color I expect you to do all your improvements in. Yeah, and then you give it to me for your assessment folder, okay, to show that you've improved. So here's the bit about colliding with the walls. Yes, so collision with the walls, it says, collisions with the walls, I'm looking about B part 1. Collisions with the wall, it says, result in forces on the walls, and force over area is pressure. So they want you to understand how forces create pressure. Yeah. They then done the mathematics the way I showed you. And then for part 3, how does it increase the pressure? And this one, it says, to increase the pressure, the particles have more kinetic energy. Yes, they're moving faster. They collide more frequently. You've got to put more frequently, or the rate of collisions is increased. So then the idea is that the particles collide with the walls with more force, yeah, or the total force is greater, and they will even allow you to put that it's the particles hit the wall harder, yes, and obviously the average force increases, therefore the average pressure will increase, okay? And then the last part is giving you a way to get the marks for the final part. These are how you get the marks, the 3 marks. They're giving you 6 ways of getting the 5 marks, or giving the 3 marks to you. Okay, I think that's the final part of the question. So the idea that pressure means higher speed or higher kinetic energy. The Tvashtar particles have more kinetic energy, therefore the kinetic energy gets converted into potential energy, which is what I said, but they're saying they have particles with the same, from both chambers, they experience the same deceleration, yes? So obviously the one with the higher speed will take longer to decelerate. That's how they done it. They done it in terms of forces and deceleration. I did it in terms of conversion to energy, yeah? So that's the 6th marking point. So different ways of explaining physics. I think my way is better, especially for students who want to go on to study A-level. Hope that makes sense to you. And that's the end of this topic test. And this is a good preparation for your mocks. And the next time we do topic tests, we'll also make you revise a topic from year 10 and a topic from year 11. So if you found this useful, please share it with your friends if they're even in the other classes. Make sure they're watching it, and use the audio to improve your answers. And subscribe if you haven't subscribed yet, because there's lots of videos I added during half term for you to revise topics from year 10, mainly forces, motion and electricity, to help you prepare for your mocks, which will be coming up in January. Thanks for watching. See you in the next video. Bye for now.